I would like to do today is to sort of do a descriptive programming kind of session where I would like to write down a few fragments of code. Read and write happen to be the most important system calls of the file management system because they do the actual data transfers. We would like to see some situations in time what kind of system calls that we use, that we employ in some of the programs. Probably we'll touch upon a few special cases also where likely that we are going to be using. And we would like to see how these system calls are usually employed, and any sort of footnotes which unfortunately you will not be able to find in a book. I would like to make my observations on that. Otherwise, normally speaking, read and write, probably we can finish the discussion in about 10 minutes. I'd like to take almost a complete session for these two system calls because we have a few other minor topics. I'd like to take that session because this is a very, very important aspect of Unix. We have the file management system, one aspect. Then we have the memory management system, second aspect. Third is the process management system. Each of these, you should have a fundamental understanding. So I thought this would be such a detailed session. And we have seen some perspective sessions so far about the open instantiations, multiple accesses, file table which contains the details of inode information in each of the rows, and so on. But now we'll get down to the actual data transfer operations. As far as Unix is concerned, read and write both are fundamentally same. Not much of difference. At least is a kind of data transfer between the process data space and the logical data blocks of the hard disk. And of course, as far as the processors are concerned, the file management system itself is the inode specialist, so it's going to give you an appearance or a picture, logical picture of a file. A file is simply a stream of bytes. So you got byte number 0, byte number 1, and so on, byte number 2, up to byte number n-1, where you got n bytes. So it's a n byte stream where n could be, of course, 1 byte, 0 bytes, or million bytes, or 100 million bytes also. There's no limit on the size of this. We have seen the actual limits are fairly large, and nobody is likely to have such large files. So this is the logical picture of the file as far as the process is concerned, even though physically these bytes may be scattered on the hard disk partition in terms of several logical data blocks, which could be practically anywhere on the hard disk. That is totally immaterial and transparent to the process because the file management system, the picture it presents is a stream of bytes. So in fact, quite sometimes you see in the manual pages when you read that, you notice that the file is simply called a stream, just a stream of bytes. Now on the other side we have, so this is one side, one part of the story. So this is like the book that we want to read or we want to write. So that is the analogy. And the other side we have the process itself and the process data space. Again, the question of process itself, we'd like to split into two parts. One part we have the actual text segment or the brain of the process. Not very interesting. The other part is the data segment. This of course really consists of four pieces. We have the initialized data segment, we have the block storage segment, we got the stack segment, we got the allocated segment, we got the attached segment, and so on. So we got a number of these pieces. But as far as the file management system is concerned, it does not really matter what part of data segment that we are talking of. This entire area, that's why we don't even subdivide that when we are having this file management system discussion. Entire area is simply known as the process data space. So that is all that we are talking of. That means you could have a data box here in the stack segment or data segment that is left as a choice to the programmer. Later on, I think when you start actually writing programs, then you'll have to decide and say, I'll have one data box in the stack segment, or I'll have a data box in the data segment, or I'll have a data box. If they're fairly large boxes like a structure or something, I'd like to have it in the allocated segment. Whatever that is, it has become part of the process data space. And file management system's primary intention, which is sitting in between these two, is to do the data transfer to or from this process data space. Now, any number of these read and write system calls are permitted. Let's just make a few observations before we get down to the details of how we're going to use this read and write system calls. First point number one is that any number of these calls are permitted. There are processes which do millions of reads and write system calls. There's absolutely no problem on that. That means we can make one assumption without loss of generality that each specific transfer, one single transfer, always does consecutive bytes transfer. Because anyway, if you want to transfer some non-consecutive bytes, you can always issue some more of those same system calls. Since anyway you can make any number of system calls, it is alright to assume that we can make only consecutive bytes as data transfer at any given on one call. That means each call itself, each one single data transfer is always going to be doing consecutive bytes of transfers. And that is something which we can assume. In fact, that is a natural assumption, like, because if you look at a book, for example, we may, of course, most of the time we would like to read the book from page number 1, page number 2, up to page number 100. It's all consecutive words we are reading. Even occasionally when we say we want to skip a couple of pages or whatever, I want to go and read the page number 100 directly. Even there, we are not likely to read 1 or 2 words, but we are likely to read at least a couple of sentences or a couple of paragraphs and so on. So that area is going to be a consecutive transfer. So we are talking of individual transfers. I'm not talking about the total thing. Individual transfers usually on the side of the file are going to be consecutive bytes anyway. So we would like to assume that to simplify these two system calls. What I'm trying to do is to evolve the parameters required for this read and write. Of course, we can look at the manual pages and write down what are the parameters for read and write system calls. I would like to approach the problem from the other side as how to design the parameters for read and write. Thinking that we are the AT&T, we are trying to design a file management system. What is the best approach to design that? Because that approach also will tell us later on when we develop our own packages and we say we need to develop a library or whatever, and we'll have to give the system calls for your system. Library is the system there, okay? Or library calls. When you say, I want to design my set of library calls, what kind of calls to provide, what kind of parameters to provide, and what are all the pros and cons. You give more parameters, what is the problem? You give less parameters, what is the problem, and so on. I think those are some of the aspects of design. I would like to cover that part of this discussion itself. Why don't we discover the parameters of read and write as we go along instead of simply just referring to the manual pages. See, that is the approach. Now, looking here, like I said, on the file side of it, most likely, most of the processors, most of the time will do only consecutive bytes transfers. Even for non-consecutive bytes transfer, there's no problem because you can always make multiple transfers. Any number of transfers are allowed. And looking back on the process data space itself, we are saying we're going to have some data box here, right? I mean, just it's where the transfer is taking place from or to, depending on whether it is write or read system call. As far as our discussion is concerned, mostly there is no difference between read and write system calls. Whenever there is a difference between read and write, I would like to specifically mention that. So, unless otherwise specified, what we are talking about applies to read equally to write also. I might just talk of one of them, of course. So, when you look at this data box, this could be practically anything. We could have, see, this data box in the process data space would be one simple built-in data type of C. That means you have this char, float, int, double, and so on. In the case of char, really no problem. There's only 1 byte. 1 byte can be considered as consecutive bytes. I mean, there's only 1 byte, right? So, no problem. Whereas even if you say I've got a long or something, which is a 4 byte value, long is not just any 4 bytes. It's always 4 consecutive bytes. Or you say I've got an array, for example. Array obviously is an array of elements, and we know that successive elements of the array have got to be in consecutive bytes, and each element itself is consecutive bytes. Or if you look at a structure, even there, what we notice is that a structure contains several members. The successive members of a structure are in consecutive bytes, and each member itself is some data type which is consecutive bytes. So we notice that whether we want to read a simple built-in data type, or we want to read an array, entire array itself, or we want to read a huge structure, it does not really matter. What we are talking of is consecutive bytes to be transferred in either direction. So therefore, we can make that simplified assumption that consecutive bytes are always going to be transferred, and the advantage of that assumption is very clear. If you know one, you know all. If you know the first byte, we know all the bytes, because once you say how many bytes are there. So in fact, you can see that if you want to work out the parameters of transfer, one is you need to know where the transfer is taking place as far as the file is concerned. So there's some byte on the file that is the first byte to be transferred. Right? Starting from this, we are talking of some n number of consecutive bytes is what we are trying to transfer. Similarly, this side, we are saying that the first byte here is probably the first byte of the first member of the first element or whatever, the first byte of the first data box which is sitting here. So that is going to be the first address. Once we know the first address, we don't have to specify anything else. So consecutive bytes means if you know the first one, you know all. So you don't have to specify anything further to the file management system. All we need to specify is actually the first byte in the file stream, stream of n bytes where the transfer should begin. First byte in the data space where the transfer should begin. And of course, next is the number of bytes to be transferred. Again, it is not a straightforward issue.